Hi, I'm Megan Crawford, period 1B, and today I'll be showing you how to solve 50. A pharmaceutical lab is conducting a study on a new drug. The lab states that a drug causes negative side effects in 2 out of every 100 patients. To confirm this affirmation, another laboratory chooses 6 people at random who have used the new medicine. What is the probability that none of them experience negative side effects? This problem is similar to those seen in our statistics unit. There are numerous practice problems in the statistics packet similar to this one. The goal of the problem is to calculate binomial probability, which can be done with the following equations. It is required that we memorize the equation. It will not be given to us on the test. To know, in fact, that our problem is binomial, it must fit all 4 binomial conditions. 1. Each observation must fall into one of 2 categories. Observations are either a success or a failure. 2. There must be a fixed number of n observations or trials. 3. The n observations or trials are all independent of each other. 4. The probability of success P must be the same in each observation or trial. Looking at our problem, we can see that there's in fact 2 categories, being success or failure. To be successful in this problem, no one experiences any negative side effects, and a failure would be that if somebody experienced a negative side effect. And the fixed number of observations or trials would be the 6 people at random, which we are only observing. In this case, it would be independent because those 6 people do not rely on each other and the order does not matter. We have a probability in this problem of 2 out of every 100 patients, or 2%, which would be the same in each trial, so our problem is in fact binomial. If it wasn't binomial, we would not be able to continue solving this problem. The equation needed to solve this problem is listed here. The first equation just says what the bottom equation is doing. So the equation states P x equals k equals n choose k times p to the power of k times 1 minus p to the power of n minus k. P is the probability of success, n is the number of observations, and k is the number of successful observations. Going back to our problem, the first number we see is 2 out of every 100 patients. And many of you will see this as our n choose k. But in fact, this is our probability. It's written out instead of in a percentage, so many of us will get tricked by this. So our p-value would be 0.02 or 2%. And to continue, the 6 people at random, as stated earlier, is our observation or n group. So our n value would equal 6. And it's asking for the probability that none of the observation group experiences negative side effects. And many of you see probability and think that's our p-value, but in fact this is our k-value because this is what they want as a success. So our k would be 0. And I find it easier to just rewrite the problem or rewrite the equation. So you will have p x equals k equals n choose k times p to the power of k times 1 minus p to the power of n minus k. And remember, we have to memorize this equation because it will not be given to us on the test. And then you simply just plug back the values that we found within the problem into the equation. So you would have p x equals 0 equals 6, choose 0 times 0.02, which is our probability, 2%, to the power of 0 times 1 minus 2% to the power of 6 minus 0. And then, since it's a calculator problem, we go into our calculator and plug all these values in. So you would start out by turning the calculator on, clearing whatever you have in there to begin with, and writing or plugging in 6, and then going to math, going over to probability, going down to option 3, which is NCR. Many of us will make the mistake and click NPR, but there's a major difference. Clicking NPR will give you a completely different answer than the one that we are looking for. So make sure you click option 3 under probability, and then hit enter. And then it comes up with your choose K. So then you would plug in 0, our K value, and hit enter to get your answer. And then you'd solve the rest of the problem. I find it easier to solve them individually and multiply them at the end because it decreases our risk of errors. So then you would do 0.02 to the power of 0, which is our k value, and hit enter and get our answer. And then you do 1 minus 0.02, which is our probability, and then do that to the power of n minus k, which would be 6 minus 0, and hit enter to get your answer. And then you'd use the arrow keys to scroll up, and then once your answer is highlighted, you can hit enter and it'll bring it back down to you, and then you hit multiply, and then you just do the same for each until you get your final answer. So then again, hit multiply, highlight your answer that you got before, and then hit enter to bring it down, and then hit enter to get your final answer. And multiply all three parts of the equation together. So your final answer would be 0.8858423809. And typically they want you to round to the nearest thousands. So the probability x equals 0 would be 0 equals 886. And that's all we have to do for this problem.